Hello guys, so this is the second problem, minimizing coins. So here we are given n coins. Each coin has a positive value. Your task is to produce the sum of money x using the available coins, such that the number of coins is minimum. Okay, so we are given the number of coins, the sum, and the value of each coin. We need to print the minimum number of coins, and if we cannot, then minus one. So How is it? How is this problem different from dice combinations? Initially, in the dice problem, we have to count the number of ways to get a specific sum x, and the values that only can be used were the values of dice up to 6. These were constant. The only thing that is changed now is this array is now uh, can contain any number of values. So comparing this question with the previous one, only these all values are changed. So now we want to count the minimum number of coins to get any number x, right? So let's say for 0, if we want to get the sum of money as 0, then how many number of coins do we need? We need no coins, that is, we need 0 coins. Okay, so let's say the values we are given are a1, a2, up to an. So now let's say we want the sum as 1. So first we'll check if any of the value is 1. So if the value is not present, like 1 is the smallest number, and as it is given that all are positive integers, so if 1 is not present in this array, then we would never get the sum as 1. So answer for that will be minus 1. And if else 1 is present in the array, we'll need 1 coin. Okay, so the general ideology is that we are moving the sum from 0 to x, we are iterating, and for each value we are calculating the minimum number of coins needed. This gives us minimum number of coins. So at any point, let's say uh, we are on index j and the sum we want is y. So what we can do is basically if we want the sum to be j, we can iterate through this array. Uh, sorry, this j is not an iterator on this array. It will be iterator on 0, 1, 2 up to the total sum x. We'll do this. Yeah, x. So let's say we are on j. So to get the minimum number of coins, let's say dp represents the minimum number of coins to achieve uh, some x. So what will dp of j say is if now we'll choose any of the coins. Let's say if I choose a1, then the remaining sum will be j minus a1. But as we are iterating initially to start, we already know j minus a1 because that lies before and we have calculated it. So if we are choosing a1, that is one additional coin, and minimum number of coins to get this value will come from dp because we have already calculated it. So j minus a1. And in the same manner, we can iterate for all an values and calculate the dp of j. So dp of j would be minimum of all this 1 plus dp of j minus ai. So this will give us the minimum number of coins required to get any sum j. Let's see the code. We take in the parameters. Okay, so what if a sum is unattainable? So how do we represent this minus 1? So what we can do is when we initialize the dp, we can uh, initialize it all with infinity. But to get the sum 0, we need 0 coins. That is known. So this is 0 and all of this is infinity just to initialize. So we always get the minimum and the right value. So as we know, this is 0. And now for each value of x, we'll iterate through the array. And another condition is we'll only iterate through those values which are less than or equal to j. That means ai should be less than or equal to j. Obviously, because this value cannot be negative. We are just considering the positive parts. So we shall use this condition and dp of I will be minimum of dp of I, or using this uh, array element dp of I minus array of j. And so we want it for x. So we'll just use that value, and if it is infinity, we'll say it is minus 1, that it is not possible, else we'll print it dp of x. Thank you for watching.